So on the left-hand side, we have 9x, and then 11 minus 4 would be 7. 9x plus 7. On the right-hand side, we have 14x minus 5x, which is 9x plus 7. And immediately when we do that, what we notice is both sides of the equation are the same, right? And so what would we say our solution would be here? If I asked you just for the solution itself. What number will work? 1 would work. Is that it? 1's the only thing that works? Every number, right? Every single number will work, okay? So here's the question you got to ask yourself. When will 9x plus 7 be equal to 9x plus 7? Always, sometimes, or never? Always. Those two will always be equal to each other, okay? No matter what number I plug in for x, those two equations, those two expressions will always be equal. So this would be what always looks like. Sometimes would be something like this. If I were to subtract 9x from both sides, I would get 7 equals negative 2. And in this case, there's no number that makes this true. So if no number would make this true, then those two will never be equal to each other. There's no number that I can plug in for x that would ever make that true. Okay, sometimes it's kind of tricky. Sometimes it would look like this. It would just be a normal old equation. I'm going to subtract 8x from both sides. I would subtract 7 from the other side. And I get x equals negative 3. And so this would be sometimes. As long as x equals negative 3, those two sides would be equal to each other. But that's the only value that would make these two equal. Okay? And so that's what would make it sometimes. Sometimes it'll be true, but not always. And definitely not never. Okay? So that's what you're doing on those. And I know the question's a little bit different, but just kind of think about what is asking. And if you had an inequality, it would be the same way. Is 7 greater than 2? That's always true, right? Is 7 less than 2? That would never be true. And so that's where you got to be careful on those two. And if I get one that says like x is greater than or equal to 2, then that is sometimes true. As long as x is greater than or equal to 2, then we would have a true statement. So if we throw an inequality in there, just ask yourself, is that equation or expression true? 6 and 7 are kind of some expression where you have to write out the expression. You don't have to solve it or anything. You're just writing out the expression that would represent that verbal statement that they gave you. Hey, 8 and 9 are the ones I was just talking about. Here's some more always, sometimes, and never questions, but it's with inequalities. So when are those two true? Are they always true, sometimes true, or never true? Okay, one thing that I would tell you on one like, on number 11, for instance. Okay, let's kind of go through this one. Whenever I see the absolute value symbol, immediately, what should that tell me? What's special about absolute value when we solve it? What would be true about our solutions most of the time? How many solutions will we typically end up with? 2, right? And so we got to remember that when I see absolute value, typically I'll have 2 equations that I have to write out. Before I can write those 2 out, I need to get the absolute value by itself, okay? So what would I do first to get the absolute value by itself on number 11? Add 6, okay? So that gives me 4. I know there's not a ton of room here to work. I should have left more room. So that's my fault. Okay, and then we're going to get rid of the 4 out in front. So we're going to divide by 4 on both sides. So this would give me the absolute value of 3x minus 1 equals 1. Because when I divide both sides by 4, that would make this 4 disappear, and over here I would end up with 4 divided by 4, which is 1. Once we get the absolute value by itself, now we can set up the 2 equations. But you got to isolate the absolute value first. You got to get it by itself. And so then my 2 equations would be 3x minus 1 equals 1. 3x minus 1 equals negative 1. And from there, I think you guys should be good to go, and you can solve from there and get your 2 answers. Because it's multiple choice, you should be able to match it up. If you ever are struggling to get there, remember that all of the problems that we have on here, for the most part, can be checked. I can take my answer, I can plug it back in. So if you ever have to go work backwards to plug it in and see if it works, then that's not a bad idea. And there might be even a way that you could solve it on a multiple choice question. I'm giving you more and more types of multiple choice questions because you're going to have the AccuPlacer that comes up in December, which is multiple choice, okay? And you always got those distractors in there that are there to kind of throw you off a little bit. Looks like the answer, but there's something not quite right about it. If you take the ACT, any kind of standardized test. And so just so you can kind of get used to seeing those types of questions. Okay, what should I notice immediately on number 12? There's a negative. Absolute value is equal to a negative. And whenever I see absolute value equal to a negative, what does that immediately tell me? No solution. I don't have to do a darn thing on number 12 because absolute value is equal to a negative. Anytime the absolute value of anything is equal to a negative number, it will automatically be no solution. Doesn't matter what's inside of it, it has to equal a negative. But be careful because like the one up here that we did, we had a negative to start with over here, but we had to get the absolute value by itself first. So don't automatically think just because there's a negative over here that it's no solution. If the absolute value is by itself and it's equal to a negative, then it will be. Okay, 13 and 14. Those are the other 2 absolute value equations. We already did one kind of like 13, so I'll let you kind of work through that one. Number 14, I think, is a little bit tricky. We had one like this on our homework, and we did some like this on our notes as well. When it says to check for extraneous solution, what that means is those are the kind that you really want to make sure you check your answer. Because sometimes I might solve it, and I might find out that those answers really don't work. So I'm going to highly encourage you to check, especially on the ones that say check for extraneous solutions. Because if you don't check it, you might not find out that one of my answers, or maybe both my answers, don't really work. All right, so 14. Very similar to what we did on the last one. I have to get the absolute value by itself. I got to get rid of the 3. Okay? First thing that you cannot do is you cannot distribute the 3. It is not parentheses. Okay? So that is a common mistake here. A lot of people want to distribute the 3 throughout the absolute value. You can't do that because it's absolute value. We have to leave the absolute value alone. But what I could do, kind of like the one we just did, is I could divide by 3 on both sides. So if I do that, I have the absolute value of 9 minus 5x. And on the other hand, on the other side, I'm going to divide both of those by 3. So 3 divided by 3 would be 1, which would just be 1x. And then 6 divided by 3 would be 2. Okay. Now here's the part that's a little bit tricky. Okay? We're still going to set up 2 equations because we have an absolute value. The first equation is exactly the same thing. The second equation is the opposite, okay? Whenever you set up your two equations, you set it up exactly the same, and the second one here is the opposite, okay? Typically, we just have a number over here, so we just make it a -4 or whatever the number is. But here we do the opposite of the whole expression. And so now I can distribute the negative through and solve. Okay? So I just wanted to kind of help you get those two set up so you kind of know the why and how of setting it up. And then now you can finish it out. I don't think finishing out should be a big deal. Just watch your signs and things like that. Okay, a hint on the story problem here. I would draw yourself a rectangle. It tells us that we have a rectangle. And the other thing that I would say here is the rectangle is 3 times as long as it is wide. So it's 3 times longer than it is wide. So if I told you the width was 4, just making up a number, what would my length be? 12, right? This is 3 times bigger than this. But we don't know what the actual value is. So instead of writing L, I'm going to write that as 3W. The reason we do that is because I want everything in a matter of one variable, because I want to be able to solve. How do I find the perimeter of a rectangle? What am I doing when I find perimeter? Add up all the sides, okay? So we're going to add up all the sides. And what do I know about the opposite sides on a rectangle? They're the same. So this would be W, this would be 3W, and then we'll just add all of our W's together and set it equal to 50. And we want to find both dimensions. So we want to find the width, and then we want to find the length. Okay. Down here, make sure you pay attention to the directions. These are our inequality ones. We're going to solve it. We're going to write the interval notation, and we're going to graph it. Okay. So you don't necessarily have to do the set builder notation. I'm not asking you to do that, but I do want you to solve it, and I want you to graph it. You'll have to make your own number line, and then tell me what it would be in interval notation. So these are the two pieces that I'm looking for especially, graphing it and the interval notation. And all of them from here on, the next page, same directions, okay? It carries over. Okay, let's do this one together. Whenever I see an absolute value within an inequality, we just talked about solving absolute value equations, but this one has an inequality in it, okay? So we're still going to write out two of them. 2x plus 4, bless you, is greater than or equal to 12. 2x plus 4, and here's where you got to be careful, is less than or equal to negative 12. Because we changed this one to negative, that makes this sign flip. Now here's the hard part. Not really hard, but you got to remember the trick. Between these two, because it's an inequality, we're either going to put the word and or we're going to put the word or. Which word would go in between here? Yeah. Or how come? Yeah, it's great or. So, remember the tricks that we talked about last week? Great or less than. This only works when you have an absolute value. The only time we do this little trick is when I have an absolute value with an inequality. Okay? Because my original symbol is greater than, then this would be an or statement. If my original symbol was less than, it would be an and statement. And now we solve it. Okay? So let's go ahead and finish this one out. X is greater than or equal to 4. X is less than or equal to negative 8. Greater than or equal to 4 is going to be a bracket because it's equal to, and it's going to be shaded to the right. Less than or equal to negative 8 would be a bracket, and it should be shaded left. And what we have to remember here is ors typically should go opposite, so that makes sense, right? It's going opposite or away from one another. And then the final thing we're going to do to finish this up, how far left is this graph going to go? Negative infinity, right? So we're going to go negative infinity up to negative 8. And then we put this little U symbol in between. And then we're going to start over again at 4. And we're going to go 4 to infinity. And that's our interval notation. So those are the things that I would want to see on a problem like that, especially the number line and the interval notation. Okay, so there's a little bit of work. Not all of those are absolute value, okay? This one here is absolute value again, right? So that one's the less than and great or. None of the rest of these do we use that. So those are the only two problems where you're going to use that little trick, the less than and the great or. The rest of these are just solving compound inequalities, but without the absolute value symbol in it. So a lot of these you're solving, but once again, you're going to solve it, you're going to graph it, you're going to write the answer in interval notation. I tried to leave enough space there that you could do all of that on those. Okay, 7 is kind of a little story problem with writing an inequality. And then on these last 3, these are just single inequalities, okay? So all we have is one inequality. They're not compound. There's no and, there's no or. We're just going to solve the inequality. We're going to get an answer of like r is greater than or equal to whatever. And then once again, you see the directions, interval notation, graph your solution set. Okay, so these are kind of the ones that we did first. They're a little bit out of order on the review, and then the test will kind of be the same way. But this is just a single inequality question. And so you're just going to have one inequality. No ands and no ors on these. Okay. Questions so far? Okay, I'm going to come around and help you guys out today. Let me know if you have questions.